So, rounding us out to lunch is Al Douglas. Al is the director at the Ontario Centre of Climate Impacts and Adaptation Resources, which is located at Laurentian University in Sudbury. Ontario. He must speak out of the country a lot, but most of us know where Sudbury is, that's for sure. He is experienced in climate science, climate change impact vulnerability and risk assessment, policy development and adaptation planning in the natural resources sector, and is a member of Canada's National Panel for Climate Change Adaptation and Resilient Results. So with that, I welcome Al to the podium.
Maybe I'll just start by saying a couple of words about our organization. We play a role in Ontario and sometimes in other parts of Canada to communicate science of climate change and develop and share resources related to climate change impacts and adaptation, but also help a variety of different stakeholders kind of undertake these sorts of risk assessments and vulnerability assessments and try to get that translated into adaptation plans and implementation. And that's kind of what I'll be talking a bit about this morning. I'll start with a few general comments about climate change and then give you some of the details of an agriculture-related project that we just completed a few months ago. You'll see Neil Comer's name on the opening slide. Neil is with Risk Sciences International and was our expert climatologist for this project. It was encouraging to hear almost all of the speakers this morning make some mention of climate change. There's no doubt that things are changing and kind of, presenting some pretty significant challenges for us. And I think in Ontario, there's been an awful lot of attention given to the mitigation side of the equation, so what we need to do in order to reduce our emissions. And that kind of ties into the big picture globally of what all countries around the world need to do in order to kind of slow down climate change. But there's also the adaptation side of the equation. It's what do we need to be doing right now as climate continues to change, and what do we need to be prepared for into the future? And that's the side of the equation that we're on, adaptation. We have a lot of good science out there that gives us insights about how things are going to change. It's grounded in our current observations of how climate is changing and has changed over the last little while. And the science, specifically the models that we have that give us a sense of how things could change, are better at projecting certain things than others. And I think we need to remember that the climate models have this kind of degree of uncertainty associated with it, but it does not mean that we use that as an excuse. The uncertainty is an excuse. We have a good, very solid understanding of what that climate would look like into the future. I've heard people have asked me, can you give me some climate projections for wind out into the 2040s in May? And it just kind of boggles me a bit because that's very, very unrealistic. And if any of you think that you can actually get those sort of projections to build into your decision making, I would say you shouldn't do that. Shouldn't do that. So the models are helpful in some areas and not as helpful in others. We also know that risk management is the big thing. We need to be looking at what those risks are and making sure that we're taking steps to have resilient systems, to make sure that people and property and economies and other assets are protected into the future in the context of climate change. But we also know that we want to be best positioned to take advantage of whatever opportunities might arise in the future with respect to climate change. So we try to strike that balance as we look into the future. Our colleagues at Risk Sciences International have developed this Climate Change Hazards Information Portal, CHIP. And they are able to take the results of all global climate models and do the calculations and project certain climatic and agroclimatic factors out into the future. And so they put together this map that shows just simply growing degree days for various locations across the country. And you can see that generally we can see some pretty big increases across the southern part of our country. So that's one piece of the puzzle that we carry forward when we think about how we are going to deal with climate change into the future. Now let me give you, so that's the general part of the presentation. Let me give you a few results of the specific project that we undertook over the last couple of years as funded through the New Directions program at OMAFRA. OCAF itself stands for Ontario Climate and Agriculture Assessment Framework, and it is a regional framework within which we want to assess baseline and future agroclimatic risks and opportunities. And when we started this work, the question that was on the table was, what do we need to be doing with policy? What do we need to be doing with policy and program in order to enable an adaptive environment and to make sure that we've got our eye on the ball as to what's coming down the pike with respect to climate change? But we all agree that those policy decisions and program decisions ought to be informed by good science. And so this project actually has both those parts. So we did the science work in order to make some comments about policy and program areas and ultimately adaptation. We pulled the team together, which is another interesting part of this, another interesting facet of the project. This is the people on the screen are a combination of private sector, us as not-for-profit, and the folks at the bottom of academia, with support from other organizations on the right-hand side as we were pulling this proposal together. And so it's truly a collaborative effort, one of those things that Rob talked about at the beginning of the day. We set out to build this framework that would be itself adaptable, but in order to understand climate change risks, it's important to apply it to specific production system or commodities and in certain regions, because we know that climate change is different in different parts of the province. And so in fact, that's what we did. We thought a little bit about the theory and thought about how we would construct this sort of framework and the inputs to it. And then we chose forage, and we applied that up in the clay belt. So we applied the framework and piloted it really in the clay belt. And then we moved down into the very southwest of the province and took a look at corn. And for us, we wanted to know the influence of climate change. We know that there's an awful lot that goes into the growth and yield. Climate change was the primary interest for us, and we wanted to look out into the future, and we did that into the decades out into the future towards the 2050s. And then, as I said, use those results to develop some insights on policy and program, and there was good engagement throughout. We had great support and advice being given to us from different associations and OMAFRA that helped us along the way. We're not agriculture specialists, we're climate change folks, so that was very, very helpful. We knew of this existing tool, and so instead of reinventing the wheel, we looked at the land suitability rating system that was developed by Ag Canada a few years ago, components of landscape, soil, and climate. And this was incredibly suitable because it already has climate built into it. And of course, this tool allows you to kind of put in the, provide the inputs and then generate scores of how suitable land is for production in different parts of the country. This sort of quantitative scoring was very interesting, and we knew that we would be able to, after looking at this a little further, we knew we would be able to introduce the change component to climate, and that would help us generate changing scores of land suitability. So let's dip into the results and look up to the north in the clay belt region and see how this played out for forage. And as we walked through the process that was kind of informed by a design document that we wrote, we took a look at the the relationships between historical climate and yield. In this case, it was Timothy. That was what we were looking at. So historical climate and yield, and ultimately the land suitability scores that exist for the north. Then we would introduce the change factor with climate change projections, and then based on the relationship that we had from historic climate and yield, we could project yield changes into the future. So now a few graphs. I said that we're in the midst of climate change. And we know that things are occurring all around us, and we usually measure climate change in 30-year periods. That's the extent, that's kind of the range. So, and we generally look at these climate normals, these 30-year periods, as an indication of baseline. Gives us a sense of, especially important for the projections into the future, that we know what we're comparing it to. So these 30-year periods, we have data that show us where we're at with these 30-year periods. So the first climate normals period from 51 to 1980, and the most recent climate normals period from 1981 to 2010. And so we already see some change. We already see above a 1 degree Celsius change, 1.5 up to 2 in some places within the Great Clay Belt, where temperature has already changed. Now this is average annual temperature. So change is occurring and we know that, but this gives us the data from which we can move forward with in climate change. Same thing with precipitation. There's different values for precipitation in the first climate normals period from 51 to 80. And then as we go forward, you can see it getting a little bit wetter in the Clay Belt when you look at the 1981 to 2010 climate normals period. So things are getting a little bit wetter. Onto the yield part of the data and the number crunching. Data was pretty sparse up in the north. We didn't have a whole lot of information, but one of our collaborators was able to point us to some research that she had done that showed us this, made this relationship between growing degree days and yield for Timothy. She had that data, kind of a loose relationship, but still better than some of the others that we looked at. So we went with this. If we're going to perturb climate and say climate change, we'll take this kind of temperature factor, and we'll use this as the component that we will look at into the future with respect to yield. Of course, you know, I said there are other things that affect growth and yield, and we found a couple of modifiers, other modifiers in the literature that also influence growth of the crop. One of them a positive influencer, the other a negative influencer, and I'll show you in a minute where these two factor in within the LSRS score. This is what the scoring sheet looks like for LSRS. So we start with the main components, and this is just the climate component for LSRS. And you can see there's a series of quantified numbers that fit into this sheet that give us the current land suitability score for the Clay Belt. And of course, there's some pretty rough terrain up there, and so it ends up having a score of 5, which is some pretty serious limitations for growth up there. And then from here, for LSRS, it's from here that we repeat the calculations for each of the 10-kilometer grid points, and we project in those decades out into the future. So on to the projections. These are some of the maps that we've produced. You can see that we have the temperature for the Great Clay Belt shown here now. These are the current temperatures. And we have all these in decades. I didn't include them all in this presentation. We could walk through slowly, and you could see as we would move from the 2020s to the 2030s to the 40s to the 50s, you would see the change. But the next graph we have is the 2050s. And so we, you know, in addition to the change that we've already experienced, we see an additional 2 to 3 degrees Celsius change within that area up in the Great Clay Belt. I guess I could also say, make a few comments about the climate modeling aspect to this. Again, all of this done by RSI, but they took I have great confidence in their climate modeling capabilities, and I believe in the different, you know, pieces that I've looked at across Canada. This is some of the best I think that we have in Canada with respect to climate modeling. They use an ensemble approach, so they take all of the global climate model output from all 40 global climate models from around the world from the last Intergovernmental Panel Assessment Report, which is number 5, and they incorporate all of that, and they use the output from all of those models. It's the right way to do it. It's not a selective choice of models. It's the use of all the models, and they take the median values. So some excellent modeling work. Same thing for precipitation. We can look at what those precipitation results are now. You can see the different precipitation levels, and as we project into the future, you can see that it's getting wetter. And we're able to resolve, kind of get better resolution with that sort of interpolation between points within the area. So what are the implications for forage in the clay belt? And I noticed that the names on the list, there's a couple of people here, I believe, from Beef Farmers of Ontario. This is, I think, particularly interesting. We know that the growing degree days are going to increase into the future. We know that the precipitation is expected to increase. And so there's opportunities for maybe more harvest that goes on, right? Maybe 2 cuts, maybe 3 cuts. And in fact, I believe we heard from some of them that this may have happened. In some years where you have the right conditions, you can actually get 2 cuts, which is good. Growing season length increasing by about 50 days into the future by the time we hit the middle of the century. And the LSRS scores, when we crunch the numbers, the land suitability scores change from class 5 to a class 3, which is pretty interesting. So with respect to the climate component of this, things seem to be getting better with land suitability. Now we link all that back to our relationship with yield, and we can see we could expect up to about a 30% increase in yield for the area, just based on that relationship with growing degree days. So we know that there's a whole lot more that goes into this. So this is, again, this is the climate component, and with none of those modifiers that were shown. Again, calculating the scores, again, there's a bit of difference that occurs across that landscape in that area. So you can see how that's shown in the maps. And Neil has actually overlain some of the roads and rail systems in there, because one of the things we need to think of is the movement of goods over the area. So a change in LSRS score. On to corn production in southwestern Ontario. Very similar graphs. We start by looking at what the climate normals periods are in the past. So we have one of the first climate normal periods from 51 to 1980, and it makes a lot of sense, right? The temperature kind of profiles as we move from southwest up northern into the province. And then the most recent climate normals period. And so you can see there is a little bit of warming that has occurred already. You know, those are from records from Environment Canada's climate stations that are set up around that part of the province. Same thing with precipitation. You can see from the records that we have, you can see where the drier areas are, and it seems to get a little wetter as we move further north within that part of the province. And we can expect it to continue. We can expect that as we look into the most recent, when we look at the most recent climate normals period, we see that it's in fact getting wetter, especially in some of those more northern locations. So what are the climate indices that are critical for corn? We chose to focus on the bottom 4 that we have on that list: crop heat units, potential evaporation, growing season length, and excess spring and fall moistures. And then we also found that there were some modifiers. So these are the things that will feed into our calculations of land suitability. Lucky for us, there was some research that was going on at the time in Carleton University from a master's student that was looking at some of these extreme event indices and how they relate to corn and what sort of influence they have on corn. And so that was very helpful for us, and we were able to choose about 5 of them out of that list that was produced and incorporate those into our LSRS scoring. So again, looking at the temperatures now, this is the current temperature kind of scan that we have in the southwestern part of the province. Warmer pockets, kind of within that region. Warmer pockets in the northwest and in the southern area. And as we look at the projections into the 2050s, you can see again it's quite similar, about a 2 or 3 degrees Celsius increase in most of the parts of that region. Precipitation. Similarly, you can see some of the values for precipitation at current. And when we do the modeling and apply the change factor, you can see that things get a little bit wetter. About a 6% total annual precipitation change, 6% into the future, into the 2050s. It's not a lot. It's not a whole lot of change. So what are the implications for corn? What is it, what does that mean for corn production? Well, we know that the heat units have increased and they will continue to increase. We know that precipitation is increasing, but according to our calculations, the increase in precipitation, and especially when you take a look at how this breaks down into the seasons, the increase in precipitation is kind of covered, or it's overcome by the temperature increases. So temperature is much more significant a factor, and we end up having more evaporation, which leads to more drier conditions, especially in the summer months. And that story really jives with a couple of the presentations and the stories that we've heard already. That just it fits very well. The growing season length is also expected to increase by about 30 days into the future. And interestingly, when we did the calculations for land suitability, the scores that we have down here in this southern part of the province, they're class 1 soils right now. They actually changed to class 2, so we have some slight limitations, driven largely by that increase in temperature that we see into the future and the insufficient precipitation that happens. And again, as when we link it back to production, see in the range of 40% increase in production. Now, some folks have told us that the numbers that we have for that historic yield values are kind of low. Some of them are pretty high, and of course, this is an average over a number of years, and so you're obviously going to have, higher years and lower years with respect to yield. But this is the sort of kind of the magnitude of change that we calculated as a result of the influence of changing climate. So again, you can see how it plays out at a finer scale over the south